In this video, I'm going to be covering question 1, part B from the 2018 AP Calculus AB Free Response Calculator Required portion of the test. I cover A, B, C, and D all in their own individual videos, so if you want to see those other solutions, please check out my other videos. Alright, so looking at B, B says during this time interval here from 0 to 300, there are always people in line for the escalator. How many people are in line at the end of that period of time at t equals 300? So to do this, let's kind of talk in general terms here. What you would want to do is sort of set up a situation where it's like, how many people are in line at the start of this process? Then what you're going to do is you're going to add in the total that enter the line. And there's also an amount of people who leave, right? And so you're going to want to subtract off the total that leave the line. So let's see what we can do to put that equation together. So to start off with, how many people are in line? Well, that's where this information in this original statement comes from. There are 20 people in line at the start. So we know at the start of this, there are 20 people in line. Then when we come to find these total amounts here, right, this is where you're going to need to apply your antiderivatives, your definite integrals. So we only have equations for the rate at which these things are happening. So we've got a formula here for the rate of people that are entering this line. And then down below here, they're telling us how many people are exiting at a rate of 0.7. So we need to total those amount up, and that's where a definite integral comes in. A definite integral is an accumulation tool. So we want to find the total amount from 0 to 300, the total amount that enter the line. So that's going to be, when you've got a piecewise function, you always want to make sure you look over here first on the right-hand side to see which equation to use. So the equation that works for 0 to 300 is going to be this top equation right here. So to get the total amount of people that are entering the line over that period of time, we would plug in this equation. T to the third, 1 minus t over 300 to the 7th. Then we're going to subtract off, this is at a constant rate. So that actually is the equation right there. So we're going to be losing people at a rate of 0.7. And then we put our dt at the end. So what we have to do here is really, we need to find out the value of this integral and then add 20 to that to get out our final answer. Well, again, the great news for us is we're on a calculator required portion of the test, so we can actually do that integral in our calculator pretty quick and easy. So what we will do is step 1 of the process, in y1 we're going to put that full equation. When you type it into the calculator, everywhere you see a t, you'd want to type it in as an x, just because whenever you're graphing stuff, you want to graph it as an x, and then minus 0.7. So put all that equation, that full equation, into y1. Step 2 out of there, we're going to go ahead and graph that, and we're going to want to make sure we adjust our window. So when we do this, the default on your calculator usually goes from an x-min of -10 to an x-max of +10, and we need to make sure that we can see x values from 0 to 300 when we're doing this process. So I would want to set my x-min to 0, and I would set my x-max to 300. Then after I graph it, step 3 of the process is I'm going to do a second calc, and inside the calc menu I'm going to choose the number 7 option, which is integral of f of x dx. The calculator is going to ask us a couple of questions, we'll answer them, and at the end it's going to say integral of f of x dx equals, and whatever that is going to give us this piece of the puzzle here, and we'll take that number, add it to 20 to get out our final answer. So I'm going to open up the calculator, go to my y equals. You should still have that equation in there. If you did this on part A, you would have had that original portion, the first half of this, already set into your calculator. And then you just needed to add in that back piece, which is minus 0.7. Then hit the window button. If you've done this on the graph for part A, then you would already have your window set to 0 for an x-min and 300 for an x-max. And so here I've got it all set up, and so I'm now just going to hit the graph button. It graphs this out for me, and now I go ahead and find the value of this. So I'm going to hit second calc. the button above trace at the very top, and then I'm going to go down to that number 7 option, which is integral of f of x dx. I hit enter on that. At the bottom of the screen, it's going to ask me 2 questions. The first question says, what's your lower limit? Well, the lower limit is our lower bound, so in this scenario, it would be 0. I type in 0, hit enter. It now wants the upper limit, so then I type in the upper limit, which is our upper bound, so 300, and hit enter. It shades it in, sort of relaxing to watch as it happens in the middle of the test. And then at the bottom of the screen, you can see that it says the integral of f of x dx is going to equal 60. So I know that the amount of people that entering and exiting at the end of all of this just totaled up to 60. So to get how many people are in line right now, I'm going to take the total amount that we started with, and I'm going to add the result of how many people entered and exited, so plus 60. And in the end, we're going to end up with 80 people in our line. So there's our final answer. This question would have gotten us 2 points, basically just one for adding in, putting this antiderivative, this equation up top here together, and then we would have gotten 1 point at the end for adding that up. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.